Good evening all, and welcome to another in our series of webinars designed to give us a better understanding of the environment and ecology of Spofford Lake. Tonight, Laura Diemer of FB Environmental will discuss the effects and risks to the lake's water quality as the surrounding watershed is developed. Since 2015, Laura has served as the environmental monitoring lead for FB. Laura has a Master's of Science degree in Soil and Water Resource Management from the University of New Hampshire and received her Bachelor of Science degree in Ecology and Environmental Science from the University of Maine. Laura knows Spofford Lake very well. She led the team which wrote the Spofford Lake Watershed Management Plan in 2018 and was the lead consultant on our 2019 EPA DES Stormwater Management Grant, which we completed in 2021. So a couple of housekeeping items before Laura starts. We plan for the presentation to be about 45 minutes with the remaining 15 minutes for questions. Please hold your questions till the end. This webinar is now being recorded, so if this is a problem for you, you need to take action now. Your microphones have been muted. If you'd like to ask a question, please push the reactions button and raise your virtual hand. You'll be recognized and then asked to turn on your microphone. You can also use your virtual hand in the chat feature. With those finished, Laura, we're pleased that you could take time and from your schedule to speak to us tonight. And with that, I'll make you the host and we can proceed.
Wonderful. All right. Thank you, Barrett. So like Barrett said, my name is Laura Diemer. I'm also a certified lake manager through the North American Lake Management Society. And as Barrett said, I'm a project manager and division lead at FB Environmental. So at FB, I manage our water quality monitoring and watershed planning projects across New England. And so a good portion of my work involves developing or carrying out monitoring, modeling, and restoration efforts for lakes, particularly in Maine and New Hampshire. And as Bear said, I'm pretty familiar with Spofford Lake, having been involved with the watershed management plan and then subsequent grants since then. So yeah, tonight I'm going to be giving a presentation to you that links watershed development to water quality. I'm going to try and highlight the water quality issues facing Spofford Lake and New England lakes generally. And I'll wrap up the presentation with some things that the town and individuals can do to make a difference with protecting Spofford Lake. So I think that you've probably all been noticing a change in Spofford Lake over the years compared to generations past. So we're seeing more muck, more aquatic vegetation, less fish, less clear water, generally more people, and you're definitely not wrong. So scientifically, we are seeing measurable increases in sedimentation or muck, as you see here, excessive plant growth, loss of some fish species at the expense of others, such as pike. We're also seeing low dissolved oxygen levels in the deepest parts of the lake, elevated chloride levels from winter road salting, and also localized cyanobacteria blooms. So the question is, what's causing this change in water quality for Spofford Lake? Well, just as the title of this presentation alludes to, water quality in the lake is tightly linked to the watershed and the activities that occur on it. So I wanted to start this presentation off with just some basic principles of lake water quality and watersheds in the context of the issues we're seeing at Spofford Lake. So starting with the basics of watershed science, what exactly is a watershed and why is it important? So a watershed is the area of land that channels rainfall and snowmelt via streams, rivers, ditches, storm drains, and groundwater to a single point. And whether that's to a lake, to a river outlet, to the ocean, wherever you define that endpoint. And watersheds help to supply the water that replenishes surface waters. So rainfall that falls down on the land, it can either soak into the ground or run off to surface waters. When it's in the ground, the water can either be taken up by plants or seep further into groundwater, which flows eventually to surface waters. And then that water evaporates from surface waters or plants back up into the atmosphere to then later fall as rain again in this never-ending loop known as the water cycle. So this water also carries with it nutrients and organic matter that's critical to supporting life, to supporting the ecology of both land and water environments. So here's the watershed area for Spofford Lake that you see here outlined in orange. So just to orient you, we are looking southwest with the outlet in the foreground. The watershed you see here covers 3.9 square miles, and all the rain that falls in this area eventually makes its way to all the feeder tributaries that enter the lake that then outlets here to Partridge Brook, which eventually flows to the Connecticut River. So whatever the water picks up along the way throughout the watershed is also being carried into the lake. And I will also want to point out here that the watershed area relative to the surface area of the lake is actually pretty small. So this means that Spofford Lake has what we call a low flushing rate. And we estimate that to be about 5 years. And what that means is that if you can imagine all the water that enters the lake, either directly through rainfall or from the watershed over the course of 1 year, it would take 5 of those years to completely replace the volume of water in Spofford Lake. So this has important ecological implications because it means that water and pollutants in that water stay in the lake for a long time and they aren't readily flushed out of the system downstream. And you'll see why that's important over the course of the presentation. So in undeveloped watersheds, the lake ecosystem is a dynamic and interconnected place that supports a diversity of species from the very tiny plankton and invertebrates to the fish and birds to mammals. And each of these species relies on the other within this intricate food web so that the health of one supports all others in this balanced ecosystem. Even the riparian buffer around the lake is so important. And it, it naturally has a multi-story tree canopy that functions to intercept and infiltrate rainfall. It can filter nutrients. It can provide important shade cover for maintaining cooler air and water temperatures around the shoreline. And the vegetation in the buffer drops in leaves and woody material into the lake and its tributaries, and that creates diverse habitats for a multitude of aquatic species. So what happens in developed watersheds is forest land that was once soaking up rainfall, stabilizing soil, has now been cleared for our homes, our driveways, and our roads. So instead of soaking up the rain, these impervious surfaces are concentrating runoff into channelized flows that then erode nutrient-laden sediments and other pollutants into surface waters where they can degrade water quality, damage critical habitat, and ultimately upset the natural balance of these ecosystems. And our activities often embed critical habitats with fill or other materials They can remove the natural filtering ability of riparian buffers, increase the amounts of nutrients and other pollutants entering these waters. And this also promotes homogenized habitats with aquatic vegetation, oftentimes invasive, tending to smother nearshore areas. We see reduced populations of critical zooplankton and macroinvertebrates, and oftentimes enhanced algae or cyanobacteria growth. Fish species can decline, bird species can decline, larger mammals tend to move out to more rural areas. So what we have left is an ecosystem that's much less resilient and unable to support life in the way that it historically could. One important concept to understand with lake ecosystems is what we call the trophic food web. So within a lake, the algae and cyanobacteria, known as phytoplankton, which you see here at the bottom, are eaten by zooplankton, which are then eaten by macroinvertebrates and small forage fish, which are eaten by larger fish, which can be eaten by birds and mammals and so on. And when one of the links in the food web is disrupted, it sends a cascading effect through the entire system. And many of our New England lakes suffer from what we call a trophic imbalance. So the abstract figures that you see here on the right showcase a classic effect and response scenario. If the top predators, such as the big game fish, are depleted because of, say, poor habitat conditions, then there's less predation on the forage fish, so their population increases. And if you have more forage fish eating more zooplankton, the zooplankton population crashes. Without zooplankton, there's no predation on phytoplankton, and the lake could bloom with algae and cyanobacteria. So all levels of this trophic food web are critical to the overall health and water quality of your lake. And why should we care about cyanobacteria? Cyanobacteria are small photosynthesizing single-cell bacteria that grow in a variety of environments, including freshwater lakes, and they come in all different shapes and sizes, as shown here in the photo collage. And we care about cyanobacteria because they can produce what we call microcystins or a variety of other toxins, all of which can pose a serious health risk to humans, pets, livestock, and wildlife. These toxins can cause neurological damage. They can also affect the liver, the kidney, reproductive organs. They can cause gastrointestinal pain or illness, eye, ear, skin irritations, seizures, vomiting, and sometimes death. We see this especially with pets who can come up to the water, they swim in the water, or they're drinking the water with high concentrations of cyanobacteria. And if it's toxic, the pets can get very ill, and there are reported cases of pets dying. So cyanobacteria blooms can form dense mats on bottom sediments. They can form dense colonies within the water column itself, or they can arise as surface scum that's usually blown towards the shoreline, as you can see here in the lower right photo. So getting back to Spofford Lake, I want to just run you through how Spofford Lake's water quality came to be what it is today. So at one point in time, the Spofford Lake watershed was heavily logged and farmed, which sent lots of organic material into the lake, where a significant portion settled into the lake sediments. Over time, the area's forests grew back and farms were replaced with residential development. Development around the shoreline, started to rapidly expand around 1980 And that coincided with changes to dam operations that increased lake levels, as well as seeing an increase in the number and power of motorized watercraft on the lake. So more runoff from developed areas combined with higher water levels and more boat wakes has really enhanced the shoreline erosion and sedimentation of that organic material into the lake. And this was confirmed through sediment core dating and analysis by Dr. Lisa Donor of Plymouth State University, who did a paleontology study of the lake a few years ago. And just as a frame of reference, the elevation of the lake today is nearly 4.5 feet higher than natural levels prior to damming about 200 years ago. So because of this, Spofford Lake has accumulated a significant layer of organic material in the bottom of the lake that continues to build from ongoing shoreline erosion and watershed runoff. At the bottom of the lake, there are microbes that feed on that organic material and break it down, also known as decomposers. And during that decomposition process, the microbes consume lots of oxygen. Now, oxygen is regularly replenished at the surface of the lake through wave and wind action, also passive diffusion. But in summer, when surface waters warm up, it creates a water temperature density gradient that prevents oxygen from being replenished in bottom waters. And so Spofford Lake faces low oxygen concentrations at depth throughout the summer months. And this matters for a couple reasons. So here is the bathymetry for Spofford Lake. The lighter blues are shallow areas around the lake, and darker areas are progressively deeper areas. And we created a line down the length of the lake, shown here in red, being sure to run through all the depth polygons to create a profile of the lake shown in this figure. So if you can follow from 0 here, matching 0 here, and when we're running this transect line to about 2,600 meters, it's following this depth profile slice that we're taking of the lake. So the data show that this area of the lake experiences less than 6 parts per million dissolved oxygen, which is a Class A water quality standard violation. So nearly half of the lake volume is impacted by oxygen levels considered undesirable for many aquatic life. This means that fish seeking cooler waters in late summer will dive down and hit this low oxygen layer, and that limits their habitat or completely forces them out of the area. The data also show that this small but not insignificant area of the lake experiences less than 1 parts per million dissolved oxygen. And at that concentration, it triggers this chemical reaction that will release phosphorus from sediments back into the water column. And we call this process internal loading. So the phosphorus that entered the lake from legacy activities or events and settled in the lake bottom can re-enter the water column and fuel cyanobacteria or plant growth today. So during the watershed management plan development process, we quantified the amount of phosphorus to the lake through modeling. The model was used to predict water quality under various development scenarios and can still be used today and updated regularly with new data. So sources of phosphorus to lake systems typically include internal loading, where phosphorus in bottom sediments are released to the water under low oxygen conditions, like we just went over. It can also come from watershed runoff from different types of land use, atmospheric dust flowing in, septic systems and groundwater flow, and waterfowl depositing their waste directly into the lake. And this phosphorus accumulates in the lake and it feeds the algae and cyanobacteria. And so we ran the model and we came up with these load estimates. So most of the load is coming from the watershed at 50%. And most of that is coming from development that's in the watershed. About 70% of that 50% is directly from developed areas in the watershed. Atmospheric deposition accounts for the next highest proportion at 25%, and then that's followed by septic systems at 15%, and then smaller amounts of phosphorus are coming from internal loading and waterfowl. So the nutrient and organic matter loading to the lake from watershed development is really further reinforcing the low oxygen issues in the lake and supports the plant and cyanobacteria growth issues that we're seeing. In particular, the internal loading for Spofford Lake, even though it's minor now, it may worsen in the future with impacts from climate change and new development. So, and we're already seeing that in many of our New England lakes, and we may already be seeing this in Spofford Lake. So there is some preliminary evidence showing that the area of low oxygen in Spofford Lake may be expanding, which would further reduce the suitable fish habitat and potentially enhance internal loading, ultimately leading to those ecosystem imbalances that degrade water quality that we talked about in the beginning. So you're looking at a figure that shows the dissolved oxygen measurements at or near bottom depths. So we're starting from 12 meters down to 19 meters here, and this is the deepest spot in the lake. And you're looking at results from 1992 in green and 2022 in red. And in all depths, the 2022 measurements had much lower dissolved oxygen than the 1992 measurements. So that's indicating that the prevalence of low oxygen in the lake may be worsening over time. And it's within a time span that's within the lifetime of everyone on this call. So what I want to emphasize tonight with all of you is that we're in a new era with enhanced effects of climate change. Even from just 5 years ago, the difference from then to today is really astounding. Lakes are changing at a rapid pace as temperatures are warming. Seasonal precipitation is becoming less predictable and more extreme. Potentially toxic cyanobacteria blooms are becoming more frequent, even in and in some cases, especially in good quality, low nutrient lakes in our region, just like Spofford Lake. So the new normal is there is no normal, and the impacts from climate change are no longer imminent. They are here now. The climate will continue to become more erratic and extreme. So keeping the status quo with watershed development is truly no longer sustainable. Our lakes are reaching their tipping points where they're no longer able to assimilate additional pollutants without these dire consequences to their ecosystem balances. And looking ahead, what does this mean for our kids, the next generation? What kind of world, what kind of lake do we want them to inherit when there comes a day when your lake may no longer be safely swimmable? So just as an example, your neighbors just 20 minutes to the east in Swansea weren't so lucky with the extreme rain events this summer that thankfully seemed to have missed your area. So here are some photos from the flash flood event in July. Massive amounts of nutrient-laden soil and organic material washed into Swansea Lake in a short amount of time. The aftermath of this event will impact their water quality for years. And the problem is that these events will become more frequent, not only in this area, but across New England. And Spofford Lake is especially vulnerable because of the watershed's steep topography, which is very similar to Swansea's lake's topography pictured here. When you have watersheds with steep topography, there's nowhere for the water to go but downhill and into the lake during big storm events. And if those steep areas are developed, the water tends to move even more rapidly downhill, and it can very easily carve out huge chunks of soil, just as you see in these photos from Swansea. And you've also seen these issues around Spofford Lake. These are just a couple photos during historic storm events that show the impact of water movement down these steep grades throughout the watershed. Removing any trees or exposing soil really allows that material to be easily transported into the lake. And now Spofford Lake is seeing cyanobacteria blooms, as shown in these photos. So beginning in 2020, Spofford Lake has suffered from blooms that are occurring as black mats of benthic cyanobacteria. And these mats do have detectable levels of the toxin microcystin, which can be harmful to humans and pets if come into contact with or ingested. And I just want to highlight that several lakes throughout New Hampshire and New England generally have started to hit their tipping point within the last 3 to 5 years. Here, I have pictures of a few examples. Each of these lakes have experienced relatively good water quality up until their first bloom in the last few years. And since then, they've suffered recurrent cyanobacteria blooms nearly every year. Long Pond, shown in the bottom right photo, was successfully treated with alum in 2022 to reset the internal loading in the lake and get back their good water quality. Lake Kennesaca, just above that, is following a similar path to that. And, climate change is creating conditions more conducive for blooms if there's enough nutrients and other elements available, which we see readily in these developed watersheds across New Hampshire and New England. So with water quality decline from blooms, there are clear correlations with subsequent property value decline, which means less tax revenue for the town and less value for sellers. It's far more cost effective to invest in preventative measures now than to pay for restoration in the future. Just some stats for you, based on a study in Maine. In one Maine city, 60% of property taxes come from lakefront properties. A 1 meter decline in water clarity reduced the property values by 5% and cost the city nearly $11 million in tax revenue. And, a reduction in recreational value of lakes also costs the local economy in other ways. If you have less people visiting, then they're spending less money in the area, recreating, dining out, shopping, touring, renting. For comparison, Baird tells me that about just over 520 properties around the lake total 28% of the town of Chesterfield's estimated $611 million property assessment value. which would equate to large economic losses with any further water quality decline of Spofford Lake. So what can we do? There's lots to do. So at the municipal level, there are many ways to protect the water quality of the lake. Ordinance changes are one, if not the most critical component of watershed protection, because remediating existing stormwater or septic system issues now is just as important as preventing any new stormwater or septic system issues in the future. And that can be done through improved planning and enforcement measures. There were several ordinance recommendations in the 2018 Watershed Management Plan for Spofford Lake. One of those recommendations was to incorporate the use of low impact development standards that minimize impervious cover, encourage open space, and manage stormwater, most especially in high grade areas that are vulnerable to erosion. The images you see here are just some examples of low impact development options that incorporate green infrastructure and stormwater control practices into site plans. The upper left photo uses permeable pavers for parking areas as just one viable stormwater infiltration option that helps to reduce runoff. In many communities that we work with, they have chosen to adopt a watershed overlay district to apply special regulations to waters for enhanced protection. It can be easier to adopt new ordinances to a smaller area of the town through assigned districts instead of having ordinances apply town-wide. And since lake protection requires timely action, any option that can help speed up the sometimes long process to adopt new ordinances is a good option. And I hear that the newly formed Chesterfield Watershed Committee is currently working on adjusting some of those ordinances in hopes to better protect water quality. And I also wanted to touch on, the individual level, the landowner responsibility. And I want to emphasize that landowners, arguably have the most power to make a difference for the lake's health and are the true stewards of the lake. The saying, death by 1,000 cuts, really couldn't be truer for lakes, because every action, whether it's along the shoreline or in the watershed, and whether it's a good or bad action, it has an impact on the lake's water quality. So if you're a landowner in the watershed and you're asking yourself, what can I do? Well, you can focus on the things that you can control, like runoff from your property. You can educate yourself on how to properly manage your land and any activities that are conducted on it to really minimize any impact to the lake. And so, some of those actions that landowners can take to help minimize stormwater and erosion impact to water quality include two key elements, infiltration and filtration. So when you're implementing these fixes on your property, you want to focus on solutions that slow down any erosive power of stormwater to really allow it time, allow time for the ground to soak up the water and trap unwanted pollutants like nutrients before reaching surface waters. And landowners can play a huge part in this just by diverting runoff to gardens or other retention areas, stabilizing shoreline access points or pathways, maintaining or enhancing their shoreline buffers, and minimizing use of any chemical, pesticide, herbicide on their property. Thankfully, there's so many resources available to help landowners with all of this. One of the best ways is to reach out to New Hampshire Lakes to become Lake Smart certified. Their staff can come out and evaluate your property, help answer any questions you have, and give you some feedback and solutions on areas on your property that could benefit from some improvements. There are a bunch of online resources you can check out. The UNH Extension has a great document, Landscaping at the Water's Edge, that's helpful. DES also has lots of materials. So the Soak Up the Rain New Hampshire program has a homeowner's guide to stormwater management. And they have a bunch of fact sheets on shoreline rules so that you can better understand, when a permit is needed or not for work that you might be doing. Make sure to have your septic system inspected and regularly pumped and maintained. And at this point, it actually might be required for you to do anyways under the current ordinance that was passed in Chesterfield a year or two ago. And then, when there are grant opportunities available, try to reach out to see if you can participate in that. It helps to fund some of this work. We've already completed a first phase through a federal but state administered grant. We call them 319 grants. We're currently in phase 2, and we're about to start another project through the Clean Water State Revolving Fund that's also administered through DES to produce engineering designs for larger scale stormwater and erosion fixes throughout the watershed. So if you would like any more information about the many topics that were discussed in this presentation, I really encourage you to go to the SLA website to find, you can find the Spofford Lake Watershed Management Plan and also the Spofford Lake Paleolimnology Report that was done by PSU a few years ago. And with that, I really thank you for the opportunity to present on this topic tonight, and I welcome any questions.
I think Cindy was our master of ceremonies.
I guess I am. I was just trying to find my find the right button here and see who's asked a question. I guess on my screen, I see Ken Walton first.
You've got to make
Yeah, can you hear me?
Yes, we can.
Okay. I think one of the main, the talk covered a lot of the things about what we can do both as a town as individuals. One area that I don't think we have any control over, and I'm interested in comments on, we have no control over the use of the lake because it's state owned. Jet skis, wake boats, other boats kick up a tremendous amount of wake along the shore and enhance the erosion of the lake. Particularly this summer where we had heavy rains, the lake level was extremely high. We had no ability as a town to restrict the use of boats until the lake level went down to more normal levels. Is there anything being done at the state level to authorize towns like Chesterfield to deal with these issues, to create some kind of restrictions to protect the lake going forward?
Yeah, great question, Ken. I know that has come up a lot, particularly this summer with the high waters across the state in our lakes. So, it's a slow process, right? Because it would need to be a legislatively driven change. But I know that New Hampshire Lakes is advocating for and doing some good work on that. And actually, I do see Andrea on the line, so she's welcome to jump in and answer that more than I can. But yeah, that it's challenging, and it's gonna take time, if it will happen. There is one lake, Silver Lake in New Hampshire, that can be regulated for that. So I guess taking a closer look maybe at how that all came about could be beneficial.
Andrea, do you have anything you'd care to add to what Laura just was mentioning?
I think Laura did a great job. And Ken, nice to hear your question. The towns do not have authority to regulate activity on the lake. So Laura's absolutely right. It would need to be a legislative change. And over the years, we've tried to, and others have tried to address the activity of wake surfing in particular. We are, not to get too much off the subject, waiting to see what happens in Vermont. Vermont is considering a 500-foot setback rule for that particular activity, and 20-foot depth and a few other things. I will say that there's, has been no political appetite for regulating that activity and other similar activities on our lakes, but that doesn't mean we shouldn't try. And Ken, we can talk more about this offline, but there is an option for groups to petition the state Department of Safety for certain operating use restrictions on our lakes. And no one has actually tried yet to try to petition against, regulate the operation of the activity of wake surfing. So it might be interesting to try the local petition process for that activity and see what happens. But again, Ken, we can talk about that more offline.
Thanks, Andrea. Next up, I see somebody named Lee.
Okay, hi, Lee Brockman here. Can you hear me?
Yes,
Yes.
we can.
Okay. This is something that wasn't touched. This is very interesting, but it wasn't touched by, this subject wasn't touched by the talk. We're in the watershed and we're being invaded by Japanese knotweed. It's also all up and down South Shore Road. It's over by the outlet. And I know we can't use Roundup on it. And it's becoming very invasive. Somebody ran into it the other day and broke a bunch of pieces down. So I had to cut it down, and I've got 3 bags of stuff that I don't know what to do to. Anyway, I think this is something that we need to also deal with, because we can't poison us because we're in the watershed.
Yeah, great point. Yes, terrestrial invasive vegetation is so challenging to manage, reduce, and really it's at this point probably impossible to eradicate, especially something like Japanese knotweed. They love growing off the sides of roads and carry their propagate from there along roadsides, and it just when it takes over those areas, it's reducing the habitat diversity in that area, right? It's outcompeting all the native species. Obviously some species adapt and try to use it, but a lot of our native species, hurt because of that. So yeah, you're absolutely right. Don't use Roundup on it. Roundup is a pretty intense chemical that will hurt a lot of our native plants and wildlife. So yeah, I mean, I'm not a terrestrial vegetation restoration expert, invasive plant person, but there are some techniques to try and at least control it and control the spread, but it's constant vigilance to do that. So I know that there are especially land trusts like to team up on projects like that and focus more on the land than the aquatic environment, which was, like you said, was more the focus of my talk tonight. So I would definitely encourage reaching out to them, and they might have some really good management strategies for you to implement.
Okay, thank you.
Chris Oot, you're up next.
Thank you. I don't have a question, Laura, but I just want to thank you very much for what I thought was a remarkably informative presentation. I've been getting involved in the lake's water quality for the past few years by volunteering on to help out with the water quality monitoring program, and I've learned just how complex lake chemistry and biology and water quality are, and how many things impact other things that you really don't understand. So thank you for enlightening us. I think that one of the things that the Spofford Lake Association has done an outstanding job of is educating the landowners and the users of the lake, because I don't think anybody wants to damage the lake. They all recognize how valuable it is to the town and to their themselves, but they don't know what impacts certain activities can cause. They can't deal with them. So I think you've done a really outstanding job of providing that type of understanding to in this presentation, and I'm glad that this is being recorded so others can have a chance to benefit from your work, and let's hope that we can all work together to keep the lake the way we want it to be. Thank you.
Thank you so much, Chris.
Thanks, Chris. I think we all give Laura a big thumbs up and appreciate all the effort that she's taken to put this really thorough presentation together. We will post it up on the website and we'll refer to it more readily. I got a couple more questions here. Bob Tortolani.
Yes, thank you. Thanks again, Laura, for the presentation. It was really excellent. I agree. You made the point that septic systems play a role in affecting the quality of the lake, and because of the ordinance, a lot of people are actually upgrading their systems or putting in new systems. And I was just wondering if indeed that these systems that are being improved are going to be getting better. How long will it take, do you think, for this change in upgrade? How long will it take for the lake to improve, if that is indeed a part of it, a large part of it?
Yeah, great question. Yeah, so obviously that depends on, what systems are being replaced, how many, where they're located, how far they are from the shoreline, the soil types that the nutrients would have to travel through, right, before they would actually get to the lake. So there's a lot of factors, but certainly something that could be modeled if you wanted a more specific quantification.
Mm-hmm.
Yeah, and yet still it's a hard question, right? Because it's not like all the septic systems aren't being replaced all at one time, right? I mean, this is occurring over a few years, so it's kind of a staggered, slow process. But yeah, I mean, usually, especially right around the lake shoreline, the septic systems are sited within the shallow groundwater. So, flushing out whatever remnant legacy nutrients might still be clinging within the soil, just roughly would probably take, at least a few years to really see that. I would like to make one point on that, though, for septic systems. It's wonderful that septic systems that are outdated are being replaced on the lake, but I do also want to make people aware that septic systems, traditional septic systems, stone and leach field, septic tank, that they're really only designed to treat pathogens from reaching groundwater and surface waters. They are not intended to treat nutrients like nitrogen and phosphorus. It's
Right.
a byproduct, but it's a fairly low efficiency. So even though those septic systems are being replaced, I just want everyone to be aware that that does not then zero out the potential phosphorus load that's coming from that now new septic system. So generally septic systems have about an 80 to 90% retention of phosphorus. So it's good. But a new system would probably be, or an older system would, maybe be maybe up to 80%. And then certainly if it's failing, maybe it's only having 20 to 50% retention. So you're not going to go to like 100% retention. There's always going to be some additional phosphorus load coming from even a new system.
Gotcha. Well, thank you very much for that answer.
Yeah.
Laura, let me ask a related question to what you were just referring to, which is the question of water treatment systems that are connected to septic and the use of traditional salt in those systems. Any thoughts on going to alternative products for any water treatment system that anyone might have?
Yeah, if someone's regularly using a water softener that's putting salts into their system, there's really nothing preventing the chloride in that to go through your leach system and be transported directly into groundwater and ultimately the lake. So chloride is not really useful for biota, any microbes, wildlife, plants. So it's what we call a conservative tracer through the environment, which means it just passes through the environment with very little uptake. So whatever you're putting into your system and is going into the leach field, the majority of that is also eventually getting to the lake.
Thank you. Anybody else have any? I think Bruce Soltis, please.
Yeah. Hi. Thanks, Cindy. And Laura, thank you so much to you and the entire FB team for all the work you've done with the watershed management plan, as well as the grant work and so forth. So echoing what others have said to thank you for that work. I was going to ask about, what we can do as individual landowners. And I think your presentation sort of covered that. Can you give a sense, and I know it's difficult without the true scope and scale of a project, but on average, homeowners may say, oh, I can't afford to do that. I mean, they seem like fairly inexpensive tweaks to our properties that we can make. I mean, can you give any sense to the average cost of some of these smaller scale projects that could still make a pretty big impact?
Yeah, absolutely. And yes, I love that, right? It's some people do feel a little daunted by it, but a lot of times, fairly inexpensive fixes can do so much good. And when you multiply that out by, even a fraction of the landowners around the lake, it does make a difference. So, if you have a path down to the lake, or an area that maybe you put your boat in, right? And, even putting like a rubber razor or just a very light berm that would just direct water instead of going straight down off your grass or your property into the lake. It's being diverted off to the side to maybe you have like a forested area. Other things, the runoff that's coming from your roof, you can easily collect that in a gutter and send it to a dry well. You can send it to a rain garden, or you can send it to a rain barrel and use that water to water your plants. And, as far as cost, if you're just talking materials alone, any of the fixes that I just mentioned, you can do for $1,000 or less, like, one of those projects at a time, I suppose, just depending on what you're actually doing. But, because most of these recommendations are plant focused. And I mean, you can buy a sapling for $50 to $100, right? And that tree, it'll take a few years, but it'll do so much good 20, 50 years from now. And it's only $50, right? And you just need a shovel, and, maybe some compost to like help it out. But, and of course, if you need landscaping help, if you can't do the work yourself, then usually, if you have an estimate for the materials, generally, if you just multiply that by 2, it sort of estimates the labor that might go with the level of effort based on materials. So hopefully that helps to answer that. But yeah, I mean, even $500, you can do quite a bit, especially if you put the sweat equity in for yourself.
That's great. Thank you.
As an amendment to that, would you care to offer any thoughts on native plantings, or how one qualifies what are native plantings and whether they are significantly better than non-native plantings?
Yeah, we highly encourage native plantings because it's just providing habitat to your native species, right? So if you're putting native plants in, your native species are recognizing those plants more readily and will utilize them. And New Hampshire has great resources, through the DES Soak Up the Rain program. They have really beautiful sheets of plants that show you, if they're good in part shade, full sun. It'll let you know if native butterflies or hummingbirds or bees, if they're attracted by that. And we use them quite frequently because they're so well put together and designed. And you can go through, they organize them by ground covers, small shrubs, bigger shrubs, flowering plants. And they're all native. So you don't have to do any work. And a lot of times the greenhouses, they're supplying native plants anyways. I know my local greenhouse has whole sections that it just makes it very easy that it's labeled as native, right? So you just go there and that the plants in that section are native to the area. And that's not to say
No, I mean, I can tune
to
off
go,
of it.
for non-native plants, because your
What are you
greenhouses are
coming
never
home?
going to sell invasive plants, so you'll never have to worry about that.
Okay, it's wrapping
But
up anyway. Okay.
if you're not doing something because the native plants don't interest you, then go for the non-native at your greenhouse. Like any plant that you put in the ground is going to be helpful. So don't let the native deter you. It's just, we encourage it.
Are there, oh wait, here we go. Judy's got a question. I think.
Judy, you're muted.
Yeah, you're muted, Judy.
One of the biggest problems I see in terms of any changes to regulation are the limitations on the town's ability to control cutting of trees on the steep slopes around the lake. We can limit development, but we find we've been hamstrung when we've tried to go after landowners who do excessive cutting. Any hope there? Because the New Hampshire Forest Lobby is evidently very strong.
Yeah, are these tree cuttings you're talking about, are they within the 250-foot buffer and fall under those restrictions? Or are you talking about
They're
more formal logging operations?
And they may not be formal logging operations. Some of it's homeowners buying a 5-acre lot and strip cutting it.
Okay. Yeah, I mean, if it's beyond that 200-foot 250-foot buffer from the lake, the restrictions do strip away pretty, pretty readily. So then it comes really down to town regulations and enforcement for that. So, and yeah, I suppose forestry lobbyists would be pretty strong there, but yeah, I guess I'm trying to find an example in my head where I can maybe give you some hope on that, but it's challenging. I've heard this complaint from a number of towns as well, and it's so hard when you're talking about private land. It's just with septic systems. They're privately owned. They are, regulated when they're first installed, but then they're pretty much forgotten about at the state and town level, and that's where we've been getting into our problems. And so that translates across other aspects as well, such as logging on individual properties. So yeah, sorry, I don't have a more hopeful answer for you.
Well, it's 8 o'clock, and it's been a great presentation. Thanks very much. But I do have one more question. My prerogative, yes. So, you know the lake pretty well. You know the watershed pretty well. You've written a report on this. You have been involved personally with the lake. You're well schooled in the things that we've done already, the ordinances that we've got. So to finish up, I know there's no silver bullet. It's obvious there's no silver bullet, but what would be your recommendations for things that we could do, the highest and best activities that we should do to try to preserve the water quality of the lake?
Yeah, no, great question, Baird. I think the efforts that you're putting in right now at the town level with ordinances, I think that is the best use of your time and energy right now. Every small improvement that you make now in your ordinances, that's going to impact new development and protect water quality. That, as soon as those start going in, they're going to make a difference year after year, decades out. The status quo that you have now, and we ran a build out analysis as part of the watershed management plan. So you were able to see, based on at least the ordinances at the time in 2018, when we were doing the analysis, the status quo for ordinances at the time, we showed what development would look like, and we were able to model how water quality would be impacted by that. And of course, the picture was painted not very well with that scenario. So anything that you can do to make new development, redevelopment projects more sustainable, controlling stormwater runoff to the lake is going to benefit you so much, especially now that we are entering this era with climate change and things are changing so quickly, and it's really out of your control at the local level. So you need to focus on what you can control so that the lake is as resilient as it can be as we deal with these crazy weather and climate changes over the years.
Okay, thank you. Yeah, that's good. Well, thanks to everyone for taking time out of their busy schedules to attend this. I hope you found it useful. I did. And Laura, thanks very much for your time. And with that, we'll call it a night. Thanks very much.